Hello. In this session, I will discuss that how you can use Simplex method to solve linear programming model. Graphical method is useful when you have only two decision variables because it is easier to plot a graph for two variables, one variable on x-axis and another variable on y-axis. But sometime in linear programming formulation, we have more than two decision variables. So to solve the problem having two decision variable, we use a simplex method. So now in this video, I will explain the step-by-step procedure of simplex method. So let's start with the simple problem, which is about a maximization problem. So we need to maximize this objective z, which is equals to 5x1 plus 4x2 subject to constraints. So let me write the constraints here. 6x1 plus 4x2, which is less than or equals to 24. Then x1 plus 2x2, which is less than or equals to 6, minus x1 plus x2, which is less than or equals to 1. Okay, and then x2 is equals to 2. Okay, so the first step in simplex method is to convert a linear programming model into the standard form. Okay, so step number one is conversion of a linear programming model into a standard form. So step number one is standard formulation. Standard formulation. Okay, so in order to get the standard formulation, we convert all these non uh, uh, all these constraints into the equality constraint. Okay, so less than or greater than constraints, if you have less than or greater than constraint. So in standard formulation, we convert inequality constraints into the equality equations. So we convert objective function into equality, which is already in equality form, and we convert the constraints, inequality constraints, into the equality equations. So first of all, let's write this. Okay, so can I write z is equal minus 5x1 minus 4x2, which is equals to 0. Okay, so similarly I can write this constraint as well. So here is it, plus 6x1 plus 4x2. Since we have a less than constraint, so in order to make it equal, so we add a slack variable, and I represent slack variable equal with s1. So slack variable for constraint number 1 is equals to 24. Similarly, we have second constraint. So for second constraint, we introduce another slack variable which is represented with s2. So I can write x2 plus 2x2 plus s2, and this is equals to 6. Okay, so now we have another constraint. So in another constraint we have minus x1 plus x2 plus s3, and this is equal to 1. Okay, so in the last constraint we have only x2, so we can write here x2 plus s4. Okay, so since we have four constraints, so we introduce four slack variable. One is S1, S2, S3, and S4. Okay, so similarly, can I write here, I can also write 0 in S1 plus 0, S2 plus 0, S3 plus 0, S4. Okay, so it doesn't change the object equation, so we can just, so that we can we will be using these as in iteration number one of simplex method. Okay, so here we have two decision variable, x1, x2, which are original decision variable, and in addition to that we also introduced four slack variable, and each slack variable is for a constraint. So S1, S2, S3, and S4. So these are greater than or equal to 0, because this is non-negativity constraint. So the step number one is just a standard formulation. Once you have converted a linear programming model into the standard form, so now we are ready to start the simplex method. Okay, so to start the simplex method, first of all, we need to convert these system of equation into the matrices. So for that, I will convert the system of equation into the matrix form. So this is our iteration number one. Okay, so first of all, we can start with the iteration number one here. I just name it iteration number one. Okay, and then first of all we need to write down some data in the table. We'll just write down the coefficient from standard form into a table. So we can write basic, then we have z, then we have two decision variable x1 and x2, s1, s2, s3, and since we have four slack variable, so we will write s4, and then we have right hand side of the equation. Okay, and then we need a ratio. I will explain what it is and why we use it, and once we fill this data. Okay, so before we start iteration number one, let me introduce you the basic and non-basic variable. Okay, so non-basic variables are those variables which have uh, which we consider equal to 0. Okay, and the basic variables are those variables which have some values. Okay, so we start with the newly introduced variable as a basic variable. For example, so here we can write down equation for z first, z, and then we have s1, s2, s3, and s4. Okay, so now x1 and x2 are the non-basic variable, and S1, S2, S3, and S4 are the basic variable. Why? Because we have the values here. Okay, so now let me write down the data in here. So what is the coefficient of z? Coefficient of z is 1, so we write 1. Coefficient of x1 in objective function is -5, so I write -5. Coefficient of x2 is -4, so I write -4. Then S1 is 0, S2 is 0, S3 is 0, S4 is 0, and on right hand side you will see that we have a 0, so we simply write 0. Okay. So the next step is to write down the constraint. So in constraint we don't have z, so I write 0, and in x1 we have 6, and x2 is 4, and s1 is 1. The coefficient of s1 is 1, so you can write down zeros, zeros, and the right hand side is 24. Okay, so similarly we can write down another constraint which is 0, sorry, here this is x1, So x1 is 1, x1 is 1, and then it is 2, it is 0, 1, 0, 0, 6. Similarly, we can write down this one. So here x1 is minus 1, minus 1, 1, 0, 0, 1, 0. Sorry, this is 2, not 0. Here, 2. 1. Okay, so now we will write down the last constraint. So 0, 0, 1, 0, 0, 0, 1, and finally here we can write down the 2. Okay, so now we have converted the coefficients of a system of linear equations in the form of table. So you can see that this column shows the right hand side of the equation, and all these columns shows the left hand side of the equation. Okay, so now we are going to start the first step. Since we are solving a maximization problem, so when we are solving the maximization problem, we always check these two variables, only non-basic variables. So here we have two non-basic variables, x1 and x2. Okay, so in these variables, if we are choosing the maximization problem, then we have to choose a column. Either we choose column of x1, either we have to choose a column for x2. But how we can decide that which column do we need to choose depends on the coefficient of objective function. If you look at in here, coefficient of objective function in okay, so a coefficient of variables in the objective function. So in this you can see, if it is the maximization problem, then we choose the most negative number or the minimum number. If we are dealing maximization problem, then we choose the minimum number, and if we are dealing the minimization problem, then we choose the maximization problem, maximum coefficient of variables in the objective function. So now since we are maximizing a problem, so I choose this 5. Okay, and I name it as so we select, I choose this column. Okay, and this column is called pivot column. Pivot column. Okay, so once you have selected the pivot column, the next step is to find out the pivot row. Okay, so to find out the pivot row, we find a ratio, and the ratio is consists of right hand side of each constraint to the coefficient of variables in pivot column. Okay, so for example here we have right hand side of constraint is 24, so we can write down 24, and the corresponding element in pivot column is 6, so you divide it with 6. Okay, so answer is 4. Similarly here we have a 6 divided by 1, which is 6, then 1 divided by minus 1, so minus 1, and then 2 divided by 0, which is infinity. Okay, so now the ratio decides the pivot row. We choose the row which has minimum positive ratio. Okay, so here you can see for all constraint we found the ratios. For constraint number 1 is 4, for constraint number 2 is 6, for constraint number 3 is minus 1, and constraint number 4 is infinity. Okay, so here we choose the minimum positive ratio. Minimum positive ratio. For pivot column we choose a minimum ratio. So for example, it's a negative, so we cannot choose it. It's infinity, too large number, so we cannot choose it. So we are just left with the 6 and 4. So our 6 is larger than 4, so we choose for this row as a pivot row. A row having minimum ratio is called pivot row, and the ratio is right hand side of equation to the coefficient of pivot column that we get in this table. So now this element is called pivot element, this element. Okay, so 6 is, this row is called pivot row, this row is called pivot row, and intersection point of pivot row and pivot column is called pivot element. We call this as a pivot element. Okay, so once we have found the pivot element, the next step is to start a new iteration. And in new iteration, this non-basic variable becomes basic variable. Okay, so this is a s1 is a leaving variable and x1 is entering variable. Okay, so now and then we make this 6 equal to 1, and if we want to make 6 equals to 1, then we have to divide this with the 6. But when we divide 6 with this, so keeping in mind the properties of matrices, that we divide on both sides, on the right hand side as well as left hand side. So after dividing, for example, so if you want to get 1 in here, so we will divide 6 on the both hand side of the equations for this pivot row. Okay, so let's say let's do it. So for example, if I divide 6 with 6, so answer is 1. Okay, so if I divide 4 with 6, so answer will be 2 by 3. If I divide 1 with 6, so answer is 1 by 6, 0, 0, 0, and then finally 4. And here it's 0, so it will be 0. So now we get new, you see, we converted this pivot element into 1. Okay, and we have equation. Okay, and we convert all coefficients, divide with 6, so that we get this one using properties of matrices. Okay, so now we will start a new iteration. I will repeat it again for you. And next, so now we can start a new iteration. So iteration number 2. Okay, so first of all, I will write down the data here. Basic z x1 x2 s1 s2 s3 s4, right hand side of equation, and then finally the ratio. Okay, so similarly here is a z. Okay, and now you will see that the s1 was a leaving variable and x1 is entering variable. So here I can write down x1. Okay, just I can use this color for x1. Okay, and then we have s2, which is the same thing, s2 s3 and s4. Okay, so to get the values for new data, okay, so as I mentioned before, that we need to convert this row. So we want to make this element equal to 1. So if we want to make this element equal to 1, then we have to divide 6 with all elements of this row. So we will get a new row for x1. So 0 divided by 6 is a 0. 6 divided by 6 is a 1. 4 divided by 6 is 2 by 3. 1 divided by 6 is 1 by 6. 0 divided by 6 is 0. 0. 0 divided by 6 is 0. And 24 divided by 6 is a 4. Okay, so now we have this new row. Okay, so I call it x1, new x1 row. Okay, and then we have other rows as well. In previous we have 0, we have s2 row, we have s3 row, we have s4 rows. So now what is the next step? So the next step is, next step we need to make all other element in pivot column equal to 0. For example, we have -5, so in new iteration we should make it equal to 0. Here we have 1, so we need to make it equal to 0. Here we have -1, so we need to make it equal to 0. So to do so, we can perform operation with the old rows and we can perform operation with the new rows. Okay, so for example, this is old 0 and I want to get new 0. So in a simplex method, you can perform operations between new x1 row, which has been selected already, and old 0. Okay, so to make old 0 to get new 0, now we can use this formula. Okay, so new 0, here I can write it. Yeah, for new 0. Okay, so we can use this column. Okay, so this one. So can I use old 0, old 0 plus 5 new x1 row, new x1 row. Okay, so first of all, let's write the new row here, old row in here. So I will just directly write down the data in here. So we have 1, we have -5, we have -4, then we have a 0, then we have a 0, then we have 0, then we have 0, and then we have 0. Okay, so now in next step we multiply 5 with this new row. Okay, so for that I use this color. So first of all we multiply -5 with 0, which is 0. Sorry, plus 5 with 0, which is 0, and then 5 with 1, which is 5. Okay, so then multiply 5 with this, which is 10 by 3. Okay, so here it is 5 by 6. 5 multiplied by 0, 0. 5 multiplied by 0, 0. 5 multiplied by 0. And 5 multiplied by 4 is 20. Okay, so now from here we can write down the answer. Okay, so from here I can write down the new row for z. 1 plus 0, 1. Okay, 5 minus 5 plus 5, 0. Okay, and if we add this, if we add these numbers and solve it together, for example, -4 plus 10 by 3, so you can solve it, -12 plus 10 divided by 3, which is -2 by 3. Okay, so I can just, so here we can write down -2 by 3, -2 by 3. and here I can write down 5 by 6, and here I can write down 0, 0, 0, and 20. Okay, so now we have found a new 0. Okay, so now we will find out new S2 row. Okay, so for that I will delete the previous rows again. In order to make a element in pivot column associated with the S2, which is 1, we need to make it equal to 0. So to do so, I will start. And so first of all, I will write down the old S2 row, which is what? Which is 1, 2, 0, 1, 0, 0, and 6. Okay, so now, okay, I think, and then here we can perform operation. Okay, so hold on. Let's write down the operations first, that which operation we should perform. So for new S2 will be equal to, since we want to make it equal to 0, so old S2, okay, minus new x1. Remember that we will be always performing operations on x1, that we got it from dividing pivot element. Okay, so now first of all I will write down the old data from S2, which is 1, 0, 1, 2, 0, 1, 0, 0, and then 6. Okay, so now we can just directly write down this equation, because we have to just subtract 0 minus 1, minus 0, it cannot be 0, so I multiply minus with the 1, 1, minus 2 by 3, minus 1 by 6, 0, 0, 0, and minus 4. Okay, so now from here we can write down directly the new S2. So the new S2 will be here we can write down 0, 0. Okay, and if we solve this, it will be 4 by 3. Okay, so we can check it out. So 4, 2 minus 2 by 3, so 3, 6 minus 2, 4 by 3. Okay, so we use this. Okay, so 4 by 3, and then which is minus 1 by 3, sorry, 1 by 6, 1, 0, 0, and then finally 2. Okay, so now we will repeat the same process for S3. So I will delete it first. So new S3 row. Okay, so now we will find new S3 row. And you see in new S3 row we have minus 1, and here we have a plus. So it means that we can simply add this row, old S3 row plus new x1 row. Okay, so simply I can write down. So let's write down the old S3 row first. So 0, minus 1, 1, 0, 0, 1, 0, 1. Okay, and here I can write down the new row, which is x1, 0, 1, 2 by 3, 1 by 6, 0, 0, 0, and then 4. Okay, so now we can simply add it so that it becomes 0. Okay, for example, here if we add 0, if we add 1 plus 1, so it becomes 0, it becomes 0, and here 1 plus 3, which is 4 by 2, or 4 by 3, which will be sorry, so we can solve it. So 1 plus 2 by 3, so 3 plus 2 is 5 by 3. Okay, so we can write down the 5 by 3. So here I can write down the 5 by 3. 5 by 3. Okay, and this one is 1 by 6, 0, 1, 0, and then we have 5. Okay, so if you look at this S4, here is already 0, so we don't need to convert this row into the 0. Okay, so I just directly write down in here, so we don't need it. 0, 0, 1, 0, 0, 0, 1, and 2. Okay, so now we have completed the iteration number 2. I will just play it. So our iteration number 2 is completed, and then we will continue to iteration number 3, and we have to continue these iteration until and unless we get a non-zero number or non-zero coefficients of sorry, zero coefficients of x1 and x2. Okay, so here is iteration number, I just name it iteration number 2. We have completed iteration number 2. Okay, so I'll just arrange it, rearrange it. Okay, so now we will start next iteration. Okay, so again we will follow the same step. So first of all, we need to identify the pivot column and then pivot element, and then again you will see that here you can see the coefficient of x1 is 0, and now and also we need to make this coefficient equals to, so which one is minimum, negative, so it is minus 2 by 3, so we choose it as a pivot column. So now the most negative coefficient of variables in objective function is 2 by 3, so we choose it pivot column. Okay, so now this is a pivot column, and also we need to find out the ratios for constraint. So here we have a 4 divided by 2 by 3, okay, which is equals to 6, and then we have a 2 divided by 4 by 3, which is equals to 1.5, and then we have a 5 divided by 5 by 3, which is equals to 3, and then we have 2 divided by 1, which is equals to 2. So now can you suggest me the lowest ratio? So yes, this one. So here now the minimum ratio is for this, so we just choose this row as the pivot row. Choose this row as a pivot row. So now this row is a pivot row, and the intersection point of pivot row and pivot column is referred as a pivot element. Okay, so now this time we have 4 by 3 as a pivot element, so this is a pivot element. Okay, so now we follow the same step, and our first job is to make this pivot element equal to 1. Okay, to do so we can simply multiply 4 by 3 with all of these numbers, and we can get the answers. For example, if I multiply 3 by 4 with this, so we can make it 1. Okay, so let's try this first. So first of all, uh, we can, okay, let me write down first the variable's name first. Basic z x1 x2 S1, S2, S3, S4, and then the right hand side. Here we have a Z. So now this is a leaving, S2 is a leaving variable, and X1 becomes the entering variable, and X2 becomes the entering variable. So we write X1, and now our entering variable is X2. So I write X2 in here, X2, and then we can write down S3 and then S4. Okay, so first of all, we need to make this equals to 1. Okay, so to make it equal to 1, so we can write down 0, 0. If I multiply by 4 multiplied by 3, if 3 multiplied by 4, so 1, 1, so it becomes 1. So here we have 1 by 6 multiplied by 3 by 4. So 1 multiplied by 3 by 4, 0, 0, and then we have 2 multiplied by 3 by 4. Okay, so now we can write down the equation in here, new equation. So which will look like that. So here we have 0. Sorry, I choose this color. Here we have a 0, and then 0, and then x2 becomes 1. And if we solve it, 3 divided by 2, so we can write it minus 1 by 8. Okay, and then 3 by 4. Okay, 0, 0, 2, 2. So we can write down 3 by 2. Okay, so now we found the new x2 row. Okay, so we found the new x2 row. So now we'll find the new 0, new s3 row, and new x1 row, and new s4 row. Okay, so this was pivot column. Sorry, let me highlight it. Okay, so let me adjust the table so that you could view the procedure. Okay, so now we can start. So now let's look at this. Sorry. Okay, so now this time we have this pivot column. Okay, so now we have to make this equals to 0. Minus 2 by 3 make equal to 0, and then 2 by 3 equal to 0, then 5 by 3 equal to 0, and then 1 equal to 0. So let's start with the new z. Okay, so for new z, we can perform calculation. New 0 will be equal to, so here we have 1. So new 0 will be equal to old 0, old 0 plus 2 by 3 new x2 row. Okay, so first of all, let's write down the new 0 data. So new 0 rate, old 0 data, 1, 0 minus 2 by 3, 5 by 6, 0, 0, 0, and 20. And now we have to multiply 2 by 3 with this. Okay, so if you multiply 2 by 3 with this, so we get this here, 0 multiplied by 2 by 3, 0, 0 multiplied by 2 by 3, 0, 1 multiplied by 2 by 3, so we can write down 2 by 3, and then we multiplied minus 1 by 8 multiplied by 2 by 3, so 2, 4. Okay, so it will be 4 minus 1 by 12, minus 1 by 12, and then 0 multiplied by 2 by 4, 0, and then 1 multiplied by 2 by 4, sorry, here we have 1, so it will be 1 multiplied by 2 by 4, sorry, 3 multiplied by, we can use this one, sorry. So here we have 3 by 4 multiplied by 2 by 3. Okay, so 1 by 2. So here we can write down 1 by 2. One by 2, and then this is 0, 0. Then we have 3 by 2, and here we have 3 by 2, 3 by 2 multiplied by 2 by 3, so it becomes 1. Okay, so now I think we can change the color for that, this line. Okay. Okay, so now we can add it and get a new 0. So to get the new 0, I can simply write down 1, 0, 0. And if we solve this equation together, for example, which is I can solve in here, 5 by 6, 5 by 6, minus 1 by 12. So 12, it's 10, minus 1, 9 by 12, or 3 by 4. So we can write down 3 by 4 in here. So here is a 3 by 4. It is 1 by 2. It is 0, 0, and if we add them, it becomes 21. Okay, so now we have completed the new 0, and now we will repeat the same step for new x1 row. So to do so, again, first of all, we will write down the old x1 row. Okay, and then to make its pivot column element equals to 0, we will multiply, for example, in x1, so we pivot column element is 2 by 3. So for new x1 row, we will multiply minus 2 by 3 with the new x1 row, with new x2 row. So first of all, I will write the expression. So new x1 row, new x1 row is equals to old x1 row minus 2 by 3 new x2 row, new x2 row. Okay, so now we can write down, first of all, I will write down the old x1 row, which is 1, 1, 2 by 3, 1 by 6, 0, 0, 0, and then finally 4. Okay, and now I will multiply minus 2 by 3 with this x2 row. Okay, so for that I choose this color, so 0, 0, minus 2 by 3. Okay, so minus 2 by 3 multiplied by minus 1 by 8. Okay, so we can subtract it here, this 4, so plus 1 by 12. Okay, and then we have another one, here is 3 by Okay, I can repeat it again for you maybe. So we need to multiply this value, sorry, minus 1 by 8, sorry, you can multiply minus 1 by 8, and it should be multiplied with minus 2 by 3. Okay, so 2 by 3 is plus 1 by 12. Fine, it's okay. Okay, so the next is that we multiply this number with the 2 by 3, 3 by 4 multiplied by minus 2 by 3. So 3, 3 minus 1 by 2. So here I can write down minus 1 by 2, 0, 0. Okay, and then we multiply 2 by 3 minus 2 by 3, 3 by 2. So 1, 1. So we can write down minus 1 in here. Okay, so after solving this equation, we get the new row for x1, which is this one. So I can write down in here x1 is 0, 1, and if we solve these equations it becomes 0, and if we solve these equation, so it becomes 1 by 4. Okay, so you can write 12, 12 plus 6, 18. Hold on. So we can add them. It's become 1 by 4. Okay, and then it becomes minus 1 by 2. Sorry, it's becomes 1 by 2. Okay, minus 1 by 2 because it's minus, and then 0, 0, and then we have 3. Okay, so this is how we complete the x1. Okay, and now we will do this same thing for s3. I will delete this all. Okay, so now for new s3, for new s3, now s3 is 5 by 3. Okay, so for 5 by 3, if you want to make it equal to 0, so it means that we multiply minus 5 by 3 with x2. So for new s2, so first of all s3, old s3, old s3 minus 5 by 3 into new x2. So we will use this operation to make this 5 by 3 equal to 0. So first of all, I will write s3 0, 0, 5 by 3, 1 by 6, 0, 1, 0, and 5. Okay, so also now I will multiply 5 by 3 with each element of this x2 row. So let's see. So if I multiply, for example, 0 multiplied by minus 5 by 3, 0, 0, and this would be minus 5 by 3. And now we need to multiply minus 1 by 8 into minus 5 by 3. Okay, so which is what? Which is minus, sorry, plus 5, 24. Okay, so here I can write down 5 by 24 plus 1. Okay, so if I need to multiply 5 by 3 with what? Now I need to multiply 5 by 3 with 3 by 4. 3 by 4. Cancel. So I can write down minus 5 by 4, minus 5 by 4, and here is 0, 0. And now I will multiply this with 3 by 2. It's 3 by 2. 3 is cancelled, so minus 5 by 2. 3 is cancelled. 3 by 2. Okay, so which is equals to minus 5 by 2. So upon solving these equations, we can get a new S3 row. So I can write in here 0, 0, 0, 3 by 8, minus 5 by 4, 1, 0, and 5 by 2. Okay. Similarly, now for S4 row, we have completed the S3 row, and now we will start S4 row for new S4 row, for new S4 row. Okay, so here we have one, so it's very simple. Old S4 row minus new X2 row. Okay, so first of all, I will write down this S4 row, which is 0, 0, 1, 0, 0, 0, 1, and 2. And now I will write down the new X2 row, which is minus 0, 0, minus 1, plus 1 by 8, minus 3 by 4, okay, 0, and 0, and minus 3 by 2. So if we solve it, so we can get the new row for S4. So here we get 0, 0, 0, 1 by 8, and 3 by 4, 0, 1, and 1 by 2. Okay, so now we have completed the iteration number 3, and you will see that coefficients in objective function equation, for example for x1 and x2, both are equal to 0. So when you get the x1 coefficient of x1 equal to 0, then you can stop it here. And you will note important thing here, so we can say it's iteration number 3. And it is very important to note that here we get the, I'll choose the different color so that I can highlight. You see here, sorry, you see here we make these elements equals to 0. And also you will important one thing more, that in this case we have this 0, 1. So coefficient of x1 is equals to 1, and coefficient of x2 is equals to 1. So you can see this is an identity matrix. This is an identity matrix. Okay, so now if we ignore the s1 and s2, so we can write down in equation form. So x1 is equals to 3, because coefficient of x1 is equal to 0, so we can relate the right hand side is equal to 0. And the coefficient of x2 is 1. Again, x2 becomes equals to 3 by 2. Okay, and the corresponding z value, you see here z, coefficient of z is 1, and here we have 0, 0. So now you can see the z score is 21. So here is a final answer. So this is how we use simplex method to solve maximization problem. So you can also solve minimization problem, but in that case you just choose the maximum number in the coefficient of variables in objective function. Okay, so I hope that this video is useful for you in solving numerical example using simplex method. Thank you.